Welcome to the Probability Podcast. Discussions on emerging and converging technologies, problems that are being solved, and the probability of positive and negative outcomes that we might expect. Now, please welcome your hosts, Jason, the generator Spracklin, and Patrick, the discriminator Lozon.
Hey everyone, and welcome to the Probability Podcast.
This episode is part of a special trilogy on the next great exploratory horizon of our planet, the ocean. We are entering a pivotal era where the abyss is becoming a space for expansion of high-tech autonomous navigation, sub-ocean habitats, and high-stakes deep-sea mining. Across these three episodes, we'll examine how we are mapping the unknown, learning to live at extreme pressures, and navigating the massive economic and environmental risks.
So in this first episode of the trilogy, we're diving into deep-sea exploration. We're currently in a new era of ocean tech where exploration is moving away from monolithic ships and towards distributed networks of smarter hybrid robots and autonomous swarms. We'll examine the shift from the massive submersibles to hybrid robots and autonomous swarms that can hibernate on the seafloor. We'll also look at full ocean workhorses like the titanium-hulled DSV Bakuana, engineered with 3D printed foam to withstand the crushing pressure of the Mariana Trench. Finally, we'll explore incredible findings from the abyss, from 850 newly discovered species and billion-dollar shipwrecks to fringe sightings like the 60-foot colossal squids and mysterious glowing orbs off the Florida coast. Join us as we explore how these advancements are reshaping our understanding of the planet's climate, the strange new life forms emerging from the dark, and why the drive to conquer the deep has become a defining challenge for humanity. So, Patrick, we know less about the deep oceans than we do about the surface of the moon, apparently.
Apparently, yeah.
Apparently.
The ocean itself, I mean, what is it? 9/5 or 5/9 or whatever is ocean of the planet, right? The planet's surface, something along that line. When we think about exploration of the ocean, we can safely say we've been along the surface of the ocean, but into its depths and understanding every crevice of the ocean, not so much.
We think about the ocean as like this giant land mass, right? Yeah. But like you said, a large percentage of it is the ocean. And I thought that was an interesting quote, kind of to kick us off, to juxtapose that against space exploration, right?
Yeah.
We think that we know everything about the planet, so now we have to go and explore outer space. But it's actually not true. There's so much of the ocean we don't know. And in fact, when you get down to the very depths of the ocean, we know less about it than we do, like you said, the moon or outer space. It's sort of like the inner space to the outer space. It's just a complete unknown in many respects, right?
Yeah, we're looking at about 27% of the ocean floors have been mapped to date. There's a project called Seabed 2030, and they want to, by 2030, be able to map, every large component of the ocean. What I mean by that is have a resolution that's 5 kilometers per pixel or somewhere around that. Mm-hmm. Get below that, right? They want to get it down to 100 meters. So the satellites, we've been able to get that, 5 kilometer per pixel resolution, but we need to dig down a little further. And the challenges around that, of course, is you just can't see, the light from doesn't penetrate that deep into 6,000 meters and 10,000 meters. It just doesn't go that deep. Radio waves don't travel through water; they disperse very quickly. The the real tool that we have to use is sonar, right? And with that, there's a process that it's like radar, or kind of like that same kind of Doppler effect, where we bounce it off the seafloor and we process the return signal, that kind of thing. But it takes time to go through and build those images.
Yeah. There's a correlation between like the deep ocean and deep space, right? That's kind of again why I made that sort of comment, was around when you think about it, it's very inhospitable to humans, right? When you think about the absence of light, when you think about the crushing pressure, the either
the cold.
extreme cold, I think in some cases maybe even extreme heat in areas, right?
Yeah.
I mean, and then you think about the just wild marine life that's down there, right? When you look at some of these documentaries about these submersibles that have gone down, like even the James Cameron documentary, I mean, literally it looks like alien life down there. And alien life not just juxtaposed to humans, like alien life compared to everything else we see in the ocean. It seems like the further down you go, the more alien-like these creatures get, to the point of like just really bizarre creatures, glow-in-the-dark type, mechanisms that they use to navigate, or it's just there's a real different world down there that we really still don't understand in terms of what actually lives down there, right?
Yeah, I mean, when you think about it, right, it's really hard to get our minds around this, but the average depth of the ocean is around 3,700, 4,000 meters, right? So, if you think about 3,000 meters, that's 4,500 psi. The depth of the Titanic, it's between, I think it's like around 4,000 psi. When you look deeper, at 6,000 meters we're at 9,000 psi. At 9,000 meters, we're at 13,000 psi. You go down to the bottom of the Mariana Trench and that kind of depth. It's 16,000 psi. That's like the weight of 100 elephants on a postage stamp. It's incredible amount of pressure. 16,000 psi. The odds of being able to survive that type of pressure for a biological entity, right? They have to have different coping mechanisms, and they have to, there's a good chance that such, life really, it can't survive even ascending, right? Being able to work at a surface level like 1,000 meters or less kills it, right?
Yeah. Look at the engineering that goes into these deep sea crafts that go down there, right, to be able to survive that kind of pressure, right? As humans, we can't, obviously, but the amount of engineering that needs to go into it. There was a quote from James Cameron that said it's important to cultivate a healthy paranoia in the engineering of a vehicle like this, right? So it's just a delicate sort of balance of like, how do you engineer something to a degree of confidence that humans can go down in these crafts and explore the very depths of the ocean. Is really mind-boggling, right? Because at some point somebody had to be the first person to do that.
Yeah.
And put a lot of faith in that vehicle that they weren't going to get crushed, right?
Yeah. I mean, there's quite a few deep sea vehicles out there that have been retired. There's like single, or maybe you can use them for a couple times, and then it's all about fatigue, the metal fatigue, and you can only subject them to so many times of this this massive pressure, and then they'll basically implode, right? And we get into, I mean, think about, was it the Titan or whatever? They brought it down as carbon fiber. It was a cylinder. It was the wrong shape. It was the wrong material. They were doing multiple dives to the Titanic. It was written kind of in stone. It's going to implode, right? It's just that was completely contrary to James Cameron's comment about being a bit of a bit concerned about the level of technology and whether it's able to survive down there with those forces, right? That all being said, we do have more than a few new vessels that are able to go down there. But we're gonna talk a little bit about the practical aspect of this, right? I mean, it's one thing to say, we've been down there to the bottom of the ocean in one little speck, right? 100 meter or 1,000 meters spot, and say that's it. I mean, that's a far cry from really exploring the ocean depths. Have we encountered the Kraken yet? I can't say that we have, but there are some very strange creatures down there. I mean, we talked about the oarfish. The oarfish is this really long fish, and it's multiple meters, and it can't survive in the upper levels of the ocean. All right, so they talk about these fish. They wash up on shore, and when they do, it's it's part of lore that it points to some kind of geological event or tidal wave or something bad is coming. And really what it is it's something is occurring at the depths of the ocean, and we're going to see it. We're going to see the results sooner or later.
Yeah, push them out of their habitat essentially, right? Because they understand not to leave their habitat. So if they leave, then there's something pushing them. It's like when you see a bunch of animals running out of a forest, you're like, there's probably a forest fire coming, right? Because there's no reason for all these deer to run manically out of the ocean and into the streets of the city or what have you, right? So there's obviously the animals, sort of fleeing in a haphazard way is always an indication of something coming, right? So and if you look at the evolution of animals, or any sort of life on Earth, it's sort of it adapts to its environment, right? So you have sort of species that can live in very extremely high temperatures, but maybe they didn't start out that way, right? So maybe through whatever process of evolution they started out somewhere, and they by necessity needed to live in a very hot area, and then over time they evolved to survive in that. You look at all the animals that have essentially evolved to survive in the frigid cold of the Arctic, right? And so I'm just saying it's an interesting correlation to we go how does this this fish or what have you survive at the bottom of the ocean? But it sort of evolved that way, or at least it was born in that habitat, and it's climatized itself to its surroundings in many ways. And that's just another reason why we can't go down there, because we were climatized to live on land in the same way that a whale was climatized to live within a certain depth of the ocean, and these animals were, or at least oddities that kind of survive in the blackness of the deep ocean, right?
Yeah, I mean, if you're used to operating and moving around, and then pressure's 10,000 psi, and then you go to the surface, it's like us going into outer space. We just literally explode,
Yeah.
And
we all learn how to adapt, right?
Well, I think that's probably they'll need suits. They need pressure suits.
Yeah.
Yeah. There's you think about it. There's lots of cases too. We're not going to get into this too much, but remember the Tonga explosion, the volcano that exploded underneath the ocean. It was I don't know, I think it's 200 meters or so below the ocean surface, but it's basically a massive volcano. And there was a good example of these we'll call them seamounts, huge volcanoes. When they go through and do the sonar, they find these things. They call them seamounts, and they're active, and they'll call them volcanoes. So we've got these underwater volcanoes, and they stir a wake, and then they shoot. They basically we don't even necessarily know that they're active until we see interesting volcanic pumice and stuff floating on the surface and that kind of thing. But they do wreak havoc to the flora and the fauna that live down there, right? And when we talk about what are the life species down there, we often can call them extremophiles, right? Because they live and grow and they're abundant in these areas where they shouldn't be, right? There's such extreme conditions, and they're not following the standard chemistry of life, photosynthesis and such. They're utilizing the minerals in the water in order to extract and basically have cellular energy. So their microbiology is actually quite different, and with that, the structure of their bodies are extremely different as well. So it is quite alien when you think about it. It's like going to, some other planet, right? So the oceans at that depth are alien to us in so many different ways. And what we're doing now is we're able to, deploy these robotic, vessels that are able to, unmanned, able to basically perform all this monitoring and take all these images and do the sonar mapping and help get rid of all these blank spots on our maps. And it doesn't mean that they're going to be able to isolate and appreciate and identify every life form that's on the ocean floor, but at least we'll get a better understanding of what's happening from a geological perspective, and we may indeed also discover some, depending on how what kind of measurements or measuring devices we use, we may actually find some really interesting species out there as well, right? And that's what I think. If you think about it, we need to do this just for the pursuit of our knowledge and the understanding of our planet, right? We shouldn't be so arrogant to say, we live on this earth and we just know everything about it. We need to understand, we need to research and explore.
Yeah, we spend so much time in space exploration, and yet, if you look at it, like we mentioned as the intro, right, over 850 new species discovered in the last 2 years alone, right? I mean, it's we're discovering coral reefs, and you said extreme life living in these vent ecosystems, and I mean it's crazy when you think about that. How long have we been able to explore oceans, and yet here we are in 2026 and we're discovering almost 1,000 new species in 2 years, right? So it shows that there's still a lot to be discovered, and it's again like space, we need technology to sort of get there, right? And that's sort of why we thought this trilogy would be interesting. That we talked last season about kind of exploring traveling to the moon and space travel. We even had an episode where we talked about telescope tech not too long ago, right? About looking out into the stars, but now we're looking inward to the ocean, right? And we're finding hidden canyons and just giant squids even, right? And things that we didn't know even exist, right? What was this about the greenish glowing orbs off the Florida coast?
Right, yeah.
What is that exactly?
Well, that's where we kind of classify that as kind of the fringe discoveries, and it's not unusual actually to basically have these glowing images in the ocean. They've actually have shots from satellite too, right? The glowing orbs, which are basically underwater by it's hard to estimate their exact depth, but they think they're fairly shallow. within the 200 meters or so. There's no real definition for them, but a lot of the situations that I talk about where they've actually encountered or mapped or took images of these glowing things in the ocean. They haven't necessarily been UAPs. They a lot of times it's life in a form of algae blooms and things like that, right?
But in some cases, could it be, right? Like they talked about extreme speed underwater objects traveling at hundreds of knots. I mean, it's not outside the realm of the possibility that, now we're getting into the, the talk of the universe and what have you, though, that something could visit the planet and decide that the ocean is the best place to kind of stay hidden from us, right? So there's so many correlations to space exploration, and we're discovering these kind of weird unknown things in the same way that we're discovering things in space that's a bit foreign, right? So it's kind of a perfect correlation. We're even discovering fossils of dinosaurs we didn't know existed, right? This like long-necked plesiosaur, I guess if that's the way you say it.
Nessie.
But the idea is it's a long-necked predator in the ocean that lived alongside the dinosaurs that we didn't know that existed until now. So there's definitely a lot of like history in the ocean as well, right?
They have drone images of it, but they don't want to go as far as to classify it and say they actually exist because the images are not definitive, let's say. So the idea behind when you're performing, when you're going into to actually explore a region, and you take pictures, you utilize your instrumentation to draw images of what's around you, and you're going to find things you don't understand, right? This is just like when we're using James Webb to take pictures of the universe. There's many people out there that'll say, okay, this is easy. This you can interpret this to be such and such, right? But yet, under further analysis, you may find that you have to go back and do further data gathering in order to isolate and understand specifically was it a shadow? Was it some kind of geological shape? Was it actually a form of life? So, that's where we get into, I'd say, the fringe side of things, because that's the fun of it, I think. Finding, massive sharks or other, monster squids and beasts of the depths, which we have little to no reference point for. Maybe some historic, reference about, some ancient Spanish galleon being sunk, but nothing about where we actually have DNA evidence, for instance, of these creatures. The only thing we got is maybe, some hulks that have been unidentifiable and they've washed up on the beach, and typically, what will happen there is they'll bury it. People will bury it because it stinks, and that's the end of that.
It's gone forever.
It's gone forever.
You made a point there about, like sunken wrecks and, discoveries there of ships that have been in the water for centuries that tell a story of history, right? So it's like, you bring up these, really ancient, I mean, some of them might be a little bit more recent, right? But like the oldest to date wreck, 55 miles off the coast of Israel, 3,300 years old, right? Many intact storage jars. Or, the Shackletons, the Quest, famous Arctic explorer from 1922, 390 meters off the coast of Newfoundland, my home. Wrecks from world wars, right? And there's a lot of history in those wrecks. So it's just interesting. There's many reasons to really not just map the ocean, but explore it, right? From species to geological discoveries and the fringe, right? The X-Files, and then or to look at the history of shipwrecks. There's a lot of stories and discoveries to be had, like in the ocean, for example, right? But maybe we can kind of shifted to, well, that's great, but how are we getting down there, right? I mean, back in the day, we would have things like submarines and different sort of submersibles, right? But now we have to get down to even further depths. So there's, maybe we can get into a little bit about, which is essentially what we like to talk about in this podcast, which is the technology. What are we using in terms of technology to get down there?
Yeah, I mean, when we looked at, Jacques Cousteau and, the old time explorers, they were, titanium-based, alloyed, very, thick-walled, 6 or 7 inch thick walls of this alloy, and spherical in nature. So the idea about when you build something that's spherical or multiple spheres placed together, you're dispersing the pressure on that object in a more uniform way, right? So like anything, forces find their way, right? So it's a weakest link thing. So in a cylinder, it's going to try to collapse that cylinder. But if you take that and turn that into a sphere, it's stronger, right? Just like an egg is strong on the two ends, same kind of thing, right? So when we think about building these vessels, right? If you take a person out of it, right, and you just put instrumentation inside there, and you shrink the size down, these vessels now are a lot more, from a cost perspective, they're a lot cheaper to build, but also more capable from a point of view of being able to go down and assume risk, right? You're not going to put a diver in danger, but it's a matter of the cost of the ROV or the SU, the specific vessel. It might be lost, right? So the intent here is to move away from manned, we'll call them high risk vessels, and go to smaller ones, right? And with that, you're able to now marry the technology of, we'll call it, the technology we use now with drones, for instance, the same kind of thing underwater, right?
Yeah, it's a smaller form factor, right? Dealing with the pressure on a much smaller form factor, much less risk, and that type of thing, which is interesting because when you talk about it, it makes sense that we can use a combination of, autonomous robots and AI and what have you to like really go down and explore the depths, and that's probably where we're going to make a lot more progress. But what I do find interesting is we still have this human need and curiosity to go down and see it for ourselves, right? It's like, why do people want to go down and see the Titanic for themselves, the Titanic wreckage, right? Because you can see a million videos and pictures anywhere online, but yet people still want to go down. And why did James Cameron want to go down in this submarine and see all this deep sea, wildlife in person? It seems like we're always wanting to have that in-person experience because it's so much different, but there's probably so much more progress we can make through utilizing, like we said, robots or smaller drone type vehicles and what have you, and all this technology that comes along with it, right?
Yeah, I mean, like I said, a lot of the initial, device or vessels that went down into the bottom of the Mariana Trench and that kind of thing, those are all retired, right? But now, I mean, we have the DSV Lackawanna, for instance. It's like I said, a titanium sphere type of build. It's 90 millimeters thick. It's very thick. Hull, and the idea was that this thing was built as a workhorse, right? So people are able to go down. It doesn't really have a limit for. Well, I guess everything has a limit, but from a point of view of being able to perform and have a dive counter and how many thousands of dives you're going to have for a lifetime of a vessel, it's on the upper limit. So you're safer in there in a lot of cases than you would be crossing a strait. right? That being said, we're still dealing with, safety margin issues. You still have to worry about the instrumentation. You still have to worry about, for instance, when we talk about what's his name? Help me out, Jason.
Elon?
No. James Cameron. Okay. I'll reframe this. When we talk about James Cameron, for instance, when he went down to the bottom of the Mariana Trench, he had a couple of the propellers actually. They had a problem. They went offline. They weren't reacting properly, and they had to work through that. And obviously they made it back up, and everybody was safe. But at that, extreme environment, anything can go wrong, right? And so it's still quite dangerous for people. And for instance, that was a good example of a vessel that was constructed utilizing a whole new type of hull material, and this is one of the things that when we start looking at technology today versus yesterday, the intent is we've got to be able to build basically constructs that can work in a very reliable fashion over many different dives versus the cost of just going down there once and then having to trash the vessel. That being said,
it has to be like resilient in a sense, right?
Yeah.
Like in the James Cameron example, he said he noted the pressure caused the sub to shrink by several inches during the descent.
Yeah.
So in other words, the pressure just caused this whole thing to really start to compact, not collapse, but to actually compact. And then, of course, the more you dive and the more you do that, then the more less resilient it's going to be to follow-up missions, right? It's kind of like the idea of going into space and having a reusable ship that you can come back to Earth and then go back again, because there's a lot of elements of going into space where things are discarded or left in space or destroyed and what have you, right? And it just creates a lot of extra cost and a lot of extra, sort of waste, I guess, in a sense, right?
Yeah. I mean, that particular vessel, the Deep Sea Challenger, I mean, it is retired, but it was, basically a first of its kind. And its hull was made of IsoFloat, which was a 3D printed material with these tiny little, glass granules in it, or spheres in it. And, the idea was that this thing was able to take, these extreme pressures and it was able to morph and shrink, but it wasn't cracking, right? It's the idea that you could bend versus break, right?
Yeah.
And if you think about it, undersea, military submarines, for instance, they'll go down, 700, 800,000 meters. Their hull will actually compress, right? And we'll see that, if you tie a string from one side to the other, you actually see that, that string start to sag down. It's noticeable. It's a very noticeable. You have respect for the amount of pressure that's involved. This whole vessel, for instance, the Deep Sea Challenger, they were doing they're manufacturing, this 3D printing this stuff, right? And resins and high strength glues and all this technology that they didn't have 30 years ago, right? So that's one side of the equation, and then we have the ability that we talked about, implementing instrumentation and having either fully autonomous vessels or vessels that basically are connected by a tether, right, or a micro tether, and you're able to remotely navigate and pass data back and forth.
Well, it gives
over
them
this
extra
tether.
range, right? So the main craft only has to go down so far. It's interesting when you think about, like, again, another correlation to things that people can possibly relate to, right? So if you look at, just to use that example of the James Cameron vessel, right? That it, at its maximum depth, it was at about 35,000 feet. Well, that's about the average, sort of altitude of a commercial jet, right? Like, I recently was on a trip somewhere, and you go up in this, sealed tube, and the pressures are high up there, and the turbulence maybe not quite as dangerous as going that far down below the ocean, but it's still an equivalent thing, right? You have to build a craft to navigate in those environments. And so if you think about when you take a flight and you look out the window and you see how high you are above the earth, well, essentially he was the same height but in depth down below the ocean. To think about that, like, conceptually, is pretty crazy to be like 35,000 feet below the surface of the ocean, in a vessel is pretty impressive. When you think about, like, the engineering that had to go into that, but also, like, the courage to, like, get in that and go down there, right, and experience it firsthand is pretty mind blowing.
Well, they did send it down by itself, unmanned, first.
Well, I imagine they did, yeah. But I mean, at the same
yeah.
time, that's maybe once or twice. Like, there's still a lot
That's
of risk associated, right?
Yeah.
Ultimately, right?
Yeah. No matter how many times you test something, things can go wrong, right? And you have to have some serious, gonads to decide. Okay, I'm going down there because, I guess the basically the collapse of the Titan, that one ship that went, or we'll call it exploration / visitor vessel. It was, it literally just, it destroyed itself. It compressed so fast. The inhabitants, the passengers, weren't able to even to realize what happened, right? It was so incredibly violent and so incredibly fast. That being said, you don't want to think about springing a leak, right? For instance, the water itself would form. We know that in the industrial side that jets of water are used to cut steel, mild steel, and things like that, right? So, yeah, you don't want to be, in the front of these a jet stream. Let's say if you spring a leak, right? So things are quite scary down there, and so that's why we're looking at more and more. We're looking at automation and utilizing robotic, autonomous vessels, and with that we can utilize this army of vessels in order to do all the sonar mapping, to basically, attack that 27% and get to 100%. We've got also some very interesting vessels that we've dispatched. It's called they call them the Argo floats, and they are basically devices, these autonomous floating devices out there that they're essentially they're around 25,000 to 200,000 in cost, and they're basically individual deep sea vessels that are their primary job is to monitor and collect data in the ocean. And so it's part of the global ocean and climate observing fleet, right? And this is a multiple country, I think there's 30 countries involved, and it's all about data gathering about the ocean. And they basically just set them adrift, right? And they can set them so they work at certain depths. They can float on the surface, but then they can also go down into the depths, and they can be programmed to go up and down on their from a buoyancy perspective. And they'll transmit data and receive data and record data, and they run on lithium batteries. They have a certain lifetime, and approximately about 10% of these Argos are lost in the ocean.
I would say it's a volatile space, right? I mean, it's when you think about it too, people go, well, why are you doing that, right? And it's a bunch of scientists just being curious, and which maybe it is to some extent, and I'm sure they're able to use AI and all kinds of technologies to really understand the ocean in many ways. I thought what was interesting about it is just this idea of like being able to understand and predict climate change, because the ocean can very much be an indicator of that, right? When you have when the climate and the patterns start to change is when you start to see different migrations of species to different areas, because the warm currents in the oceans change, or again, sometimes you have the perfect scenario in the ocean that is ripe for sort of a giant hurricane or whatever to form. And if you can understand where some of that's happening in the ocean and what's happening, you can predict some of these weather events in a different way, right? Everything's connected. We think the ocean is just there, but it's very much a part of the entire ecosystem, and whether that's just sort of larger climate change shifts, or whether that's short-term massive storm systems, it's all connected in so many ways, right? And a giant hurricane can feed off the ocean in many ways, right? So it's kind of there's a reason for all of it, and I think that's why I thought this was interesting to kind of dig into. And there's various reasons to go down and look at the depth of the ocean, or look into the depths of the ocean. But this is just one of them, right?
Yeah, monitoring salinity, monitoring temperature, monitoring current strength. We've been able to isolate and measure, the heat plumes and the collection of heat over the course of a number of years, right? Since we've had the Argo fleet dispatched, this helps us when we think about the volatility that of weather that this would contribute to. As we understand, the different currents, as we understand the different levels of ocean water and those particular, we'll call them substrates or physical levels of the water, different levels of salinity, different levels of temperature, and the currents that run with them and in them. These are complex structures within the water, and being able to understand this movement and these flows and what is affecting them also ties back to our bigger picture of understanding what they can do, for instance, with weather, what they can do from a point of view of melting glaciers, right? We think about the Thwaites, the Antarctic glacier, and the fact that we have specific autonomous vessels that go down there to measure and monitor, take pictures of what just the glacier and where it's grounding at, and what is the level of the ice to the bottom, to the ground, the actual, basically that particular glacier is kind of hung up on the ground, and once the ocean is able to wash up underneath it, it will be able to be flushed out. And once that particular glacier is set free, into the ocean, it basically opens up a large area of the remaining ice sheets to start flowing out at a rapid rate. And this is why they call this the Doomsday Glacier. So they're doing a lot of under ice investigation and imaging and data collecting with these autonomous vessels, just to understand what's going on.
Episode. Sorry, I was gonna say it just wouldn't be an episode of the Probability Podcast if Patrick didn't get to some doomsday scenario.
Yeah. I mean, I didn't label it that, but yeah, it's a doomsday scenario from a point of view of the potential that it has for that glacier to contribute to the rise in ice levels. I think it's something like, I don't know, I could be wrong here, but it's up to 60 meters, something along. It probably wouldn't be that much, but it would put a large amount of our coastline underwater across the
which
world.
is sort of a bad thing, right?
Yeah,
Something we don't want. I thought the idea of the heat sponge was interesting. You know, that we're talking about the ocean, climate, and what have you, right? Like, the most critical finding from this Argo array is that the ocean is absorbing over 90% of the excess heat trapped by greenhouse gases, right?
Yeah.
2025 set a new record for what they call the ocean heat content, the OHC. The heat added to the ocean between 2024 and 2025 alone was equivalent to 210 times humanity's annual electricity generation. I mean, I don't know really what to make of those numbers, other than they seem pretty astronomical to me, and it can't be good for us to be generating, you know, all these greenhouse gases, and then for the ocean to be absorbing all this excess heat. I mean, even outside of, you know, extreme, you know, weather events and what have you, I mean, there's all these sort of species and habitats that are going to dramatically change because of the, you know, the warmth of the ocean is rising, right? And there's, you know, species that are used to living in colder climates that are now either going to have to migrate or they're not going to survive. And it's very, you know, sort of, it's a data point that's kind of concerning. Interestingly enough, like, many years ago, probably over a decade ago, you know, I'm originally from the island of Newfoundland, and I think one of the first times I took my now wife to the island, she wanted to see whales, so we went out on a, you know, whale watching tour boat, and you know, with all the excitement that we're going to see whales. And what was interesting is we didn't see any whales, which, I mean, you don't always see whales out there, but we did see, to my surprise, was dozens and dozens of dolphins. And the idea that there would be dolphins in the ocean off the coast of Newfoundland was sort of mind-blowing to me, right? Thinking that dolphins always live in more like tropical waters, and I almost couldn't believe what I was seeing in the water, because I grew up my whole life up until I was almost 20 years old in Newfoundland, never saw a dolphin in the ocean. Saw lots of killer whales and humpback whales and all kinds of other marine life, never a dolphin. And the explanation was basically that because of all the shifting of currents, there was all this warm water off the coast that wasn't usual, and that the dolphins had just made their way there because of that. And it was a sort of an unusual sighting. So I thought that was just an interesting anecdotal experience, you know, from my perspective of going out on a whale watching, you know, expedition, and all of a sudden, I mean, there was just dozens of dolphins just following the boat and just jumping out. I have videos and pictures of it, and I mean, I'd never seen that in 20 years of growing up on the island, right? And I'd been out on boats and ships, so it was quite something.
I mean, the idea is, you know, it's one thing to think about just temperature, but with temperature can affect or lead to, like, it's a domino effect of affecting life, right? So it can drive ocean acidification. So this can modify the pH levels indirectly, right? And, you know, if you see, you know, have an ocean or a large level of the ocean water becoming more acidic, that can effectively kill off coral reefs, you know, and just keep promoting, you know, algae blooms and that kind of thing. There's also what we call oxygen, you know, we've got basically a declination or a decrease of oxygen levels in the ocean. And these can cause great areas of the ocean where, life can't, or the standard life cannot grow. You don't, all those fish and whales and whatever, sea life, even crabs, lobsters, what have you, they just cannot survive, right? So from our point of view, we're just looking at the surface of the water, right? We're not seeing down deep how all this is, chemically, how all this is changing, with the temperatures. So there's a lot of unknowns about, this great heat sink. And there's a lot of people out there that talk about, climate change, global warming, doesn't exist. Oh, it does. But you have, these oceans around us that are, tens of thousands of meters deep. They soak up a large majority of that heat, and they are changing underneath. They're changing under the surface. We're just not knowledgeable of all those changes, and that's why we have to monitor all this. That's why we have to learn, and we've got a lot more to learn in order to build up trends, in order to isolate, fact from fiction, or what are the real, indicators of change, or is this just a reading that is taken out of context and we don't really understand it, right? So it's very important to get a full breadth of understanding across all the oceans, and monitor that data and start getting a handle on what this really means to us as a species, how it can affect us. So that being said, we also got to really think about what we have from a point of view of the technology on a military side, because we've talked about the idea of discovery and monitoring and geology and where we're going to understand the oceans, but the other side of it, of course, is defense, right?
Why are we doing that though, right? Like why is the military interested in the ocean, one might ask, right? And obviously it's another area where there can be sort of, potential for warfare. There's sort of, espionage and surveillance, of other countries, right? The ocean's just another way to navigate as opposed to the air, right? But there's also things like, 99% of global data travels via deep sea cables, and in fact, you've seen examples of that, right? Like there was an example of some sort of deep sea cable over on the east coast of Newfoundland or somewhere off the east coast that was that they discovered this underwater line had broken, or they thought it had broken, and when they went down they found it was intentionally cut. And I think it's pretty deep down, right? And it's a huge communication line, and I don't know if they ever did find out who cut it, but kind of concerning in a way, right? But when a huge portion of the communications through the internet is traveling through an underwater cable, and then they find out it's being cut, then it's pretty clear that somebody's looking at it as a way to sort of isolate and cut off communications, right? There's also underwater, connectors between countries for power grids and that type of thing, right? So I mean, there's also, which we'll get into in later on in the trilogy, the the valuable minerals and things in the ocean, right? And countries laying claim to the ocean, and being able to sort of build riches, right, and that type of thing. So there's sort of this idea of having to sort of guard underwater territory. So it seems like there's a number of different reasons, around why the military is interested. Like, why else would they be interested in your research?
Yeah, I mean, when we look at that, for instance, there's espionage, right, like you said, but there's also political activism. I think there's a case in 2022, the Nord Stream natural gas pipelines in the Baltic Sea were, three of the four, or was it three of the pipelines were destroyed, or four of the pipelines basically destroyed at a certain spot, so they were leaking, polluting insanely. In the Baltic Sea, there was a Chinese bulk carrier who was suspected of intentionally dragging its anchor to cut a large communication cable. This was in November 2024. The same kind of tactic was used to cut another cable in 2024. It was an oil tanker. So, it's not outside the possibility that these communication cables and different underwater resources, for instance, for oil and gas, are our political targets, right? And while you think they're under the cover of 1,000 meters of water, you can still through specific types of vessels manage to destroy this property, even though it's technically very difficult to manage, right?
Yeah, for sure.
Yeah. That being said, this is also now becomes an asset for protection. I mean, not only do we, countries have to properly monitor and or respond to, a vessel entering their 200-mile shoreline limit. They also have to monitor under the sea for vessels as well, the submarines, right? So this is where our new technology is really helping us from a point of view of being able to have these autonomous vessels, right, that can essentially park themselves and monitor. And when it comes to isolation of specific readings and or launch themselves to investigate those particular signals and or respond to it from a point of view of possibly deploying explosives and such. So a good example here, there's a manta ray AUV developed by Northrop Grumman for DARPA, and it's really a ongoing, persistent ocean presence. It can run by itself for many years, and you put them out in a whole array into the ocean, and they're tactical, right? And that being said, they can monitor their buoyancy, they can move about, and anchor themselves. At the same time, if they need to be deployed, they can deploy, and they can move quite quickly underwater because they're quite efficient with their designs, right? Their overall shapes. They can do high speed maneuvers, so they can actually outpace a lot of vessels like larger submarines and ships. So, yeah, can they, continue to use recharge and build up energy down there? It really depends on how their anchoring technology works and whether or not they have their own type of power generation, or they're even nuclear, small nuclear reactors, that kind of thing. But a lot of the technology today is, they're basically powering up via tether, right, with underwater docks. So that's a very interesting technology, and the intent there is, and we've got many different versions of this being utilized throughout the globe. There's the Orcas, the U.S. Navy combat vessel. It's like a mini submarine, and it has a payload bay. It's able to perform mine laying. It it's running on older technology like a diesel, diesel electric, but it can basically cross the ocean by itself. There's ghost sharks in Australia. Again, a newer technology, but think about the challenge for Australia, similar to Canada. Extremely long coastline. How do you protect that cost effectively? How do you monitor cost effectively? How do you respond cost effectively? So it's not by manned vehicles, right? The manned vehicles are really going to be the exception. We're turning more and more into developing these drones that can, essentially park themselves and respond, and monitor and respond, right? There is another one. It's called the Russian Poseidon. It's a bit of a strategic nuclear weapon, and it's designed to dispatch multi-megaton nuclear warheads. Now that particular, we know about submarines, but now we're moving into, drones that can be remotely triggered to basically launch, we'll say very, very large explosive devices. I'll just leave it at that. Your imagination can, and China's got their own version of this type of vessel. It's about monitoring and managing all types of threats in the ocean around, the security of around your country, but also deep sea support. And to if you think about these smaller autonomous vehicles can be also accompanying in a large numbers around your naval vessels and other vessels, and used as a extrasensory devices. It's a big area of investment for companies and to build these military devices, and for countries to engage in them. It makes sense, right? It's a cheaper solution than building manned vessels, manned submarines, and what have you.
What's a similar type approach to what we're doing with sort of warfare in the skies, which is you're a lot more vulnerable, right? Whereas if you can, for example, create craft similar to what we've described just for exploration, but now you apply that to military, now you have something that can really go deep below the ocean and not even be detected, or at least once it's detected it's too late. Is interesting how we apply the same types of technologies but to a different medium, being the ocean versus the sky, right? But also in some ways I kind of go like, okay, well, this is just another example of us really invading a habitat that's not ours, right? I guess that's could be applied across the board, right? Whether we're just diving down to the depths for scientific exploration, which in essence, I guess for the most part that's kind of good natured, or at least has good intent, right? That we're trying to understand the ocean so we can better take care of it. In some cases where we have all these other ulterior motives, right? And all sounds good in theory, and it sounds good that we want to protect, the country and what have you. But now you have all these, huge vessels and drones and everything operating within a habitat, and all, the natural beings of that habitat are kind of going like, what the heck's going on here? In essence, right? We're disrupting these ecosystems in many ways, right? So there's like one side of it in which we're trying to do this scientific exploration, and discovery, what have you, and then there's the other side, which is sort of the military side, and we'll certainly get into some other subjects in some of the upcoming trilogy of episodes, right, where we'll talk about sort of like habitats, right? So we've talked about exploration, we're going to get into habitats, we're going to get into mining, which is a whole interesting area, which we kind of touched on, today, the reason for, exploring down there. But those are sort of,
Commercial,
encapsulated themes in and of themselves, right? But so what do you think ultimately about, this sort of foray into the ocean? There's certainly a lot of benefits, a lot of, potential disruption, and is it ultimately going to be a good thing for humanity?
I think any type of exploration is going to end up with a multiple invention and multiple creation of different types of technologies, and that's a good thing. We shouldn't be requiring war, to push our technology, push our invention, push our development of new and wonderful, devices and technologies and materials and methods. Right? When we take on these types of projects and attempt to do something that mankind's never done before, it's a learning process. But it's not any different than when NASA went to the moon and invented these ceramics, and we the commercial Corningware, what was a good example of what came out of that. So yeah, I love to foster and push the envelope of new problems and new solutions.
Yeah, absolutely. But don't forget, Patrick, the ocean doesn't give up its secrets easily.
Thank you for listening to the Probability Podcast. Please join us next time for